Hi everyone. Welcome to the new video, and it is the second part of the video of atom and its structure, right? So in this video, we are going to basically cover, as you can see on the screen, also on the title, that this is going to be about the laws of chemical combination, right? Which is the second portion or second part of what we have done in the introduction, right? After this, we'll be covering more of the parts of this chapter. And without wasting much time, let's begin, right? So this is the video about the laws of chemical combination. Now, what are they? What are the laws that we need to understand in this topic? And with the examples, we are going to master this. Okay, let's begin. So, what's the deal with chemical combination? So basically, let me explain you this thing, that in chemistry, we have, different atoms or different elements which combine together and uh, they form a different element, right? Right? Let's show over here. Let's see over here. What am I talking about? So, for example, hydrogen, there are two hydrogen and one oxygen that combines to form the water, that's H2O, right? So this is two different elements, hydrogen and oxygen are the two different elements which combines together to form a compound, and that is what you have is H2O, or which you simply call as water, right? Another basic example, let's take, is sodium, Na, plus chlorine, Cl, gives you NaCl, that is sodium chloride, and which is nothing but your basic table salt. You know that table salt. That is what the thing is. Now these two different elements, they are combining together. It may be more than two, of course. So they are mixing together, combining together to form a different compound, right? And on this thing, there are a few laws that are being followed. Okay, they just don't mix up. Normally, they have some laws that they follow to get mixed up and form a compound. That is what the laws of chemical combination are. Let's quickly read it out. So, hey, young chemists, imagine chemistry as a magical kitchen where elements mix to create awesome compounds, right? But there are rules to this magic again. These are the laws of chemical combination. They're like recipes, that keeps atoms in check. No random cures here. You know how to, make your Maggie. That's what is. Like everyone has a different recipe though, but you like the way you make it, right? So you have a set recipe for that. That maybe I like my Maggie with a lots of veggies. So it's mandatory for me. For some people, maybe it is not a deal. They just like to boil it and have it. That's also a way of having it, right? So there is a law, there is a fixed law how the things work. So no random cures. We'll explore two cool laws with fun example and chemical symbols like H. H is for hydrogen. Think of the tiny balloons like this. Okay, now, O, and O is for oxygen. Oh, come on. We all know what is an oxygen, the breath of life, right? So that is what we are going to understand, right? Now, let's move on to the first law that is there in the laws of chemical conservation. Chemical combination. There are many, not many, like there are 4 or 5, but we don't need to do those all because they are somehow the replica of these two only. But let's try to understand what are the two main and important laws under the law of chemical combination. The first one is the law of conservation of mass. Now, by now, you know what is, the meaning of mass is, right? Generally till this point, we do not actually differentiate between what is a mass and what is a weight, although they two are both different things. But let's consider the mass as the weight. elements this time, right? And the conservation obviously means to conserve, to restore, to to store. That is what the conservation means, right? So with no magic trick rules, so what is this? Let's try to understand. So the first law, that is law of conservation of mass, was discovered by Antonin Lavoisier. Okay, please remember this name as it's really important. Why? Because this chemist was known as the Sherlock Holmes of chemistry. He is the Sherlock Holmes. You know who is Sherlock Holmes? Exactly, the famous, the famous person, the investigator. That what Sherlock Holmes is, right? So the something over here. This is used as the exception or the wonderful one from his field. So that is what he is. Now, this law says in a chemical reaction, matter doesn't disappear or appear out nowhere. Okay? The exact description is the total mass of the reactants equals the total mass of the products. Now, what are these reactants and products? Let me show you. So here we have written this rule of H2, H2 plus O gives you H2O, right? So this side is on the left side, you call this as the reactant side. These two elements are reacting together, right? So on the left side, you call it as the reactant side. Reactant side. These two are reacting together and then they are forming a different compound, and that is what the product is. This side on the right, that is called the product, right? So, when the reactant and the product, when they react each other, the total mass, like both the sides, the mass is same. That means over on this side, the reactant side, for example, let the mass be X on this side, it will be same on the other side, the product side as well. So this side also it should be or it will be X, right? This is what the starting stuff is, and this is what the ending stuff is, right? Now it's like a balanced seesaw. You all know what is a seesaw, right? So it's like a balanced seesaw. On both the sides, the mass, see, the seesaw only balances when both sides will have the equal weight, right, or equal mass. That's what we are trying to explain over here. That on both the sides, the reactant side and on the product side, it is the same. Mass is the same. Now, why is it cool? Think of baking cookies. The dough doesn't vanish, when you prepare the dough and then you keep it in the baking tray and then you bake it, right? Before baking, it was just a dough, right? But after baking it your cookies, it turned into your cookies. The dough doesn't vanish, right? It turns into the cookies. In the chemistry, atoms just rearrange themselves, keeping the mass same, right? Let's take an example. So let's make water. Now, hydrogen twice, H is the symbol for hydrogen. Now, two hydrogen atoms and two oxygen atoms, though, it combines to make two H2O. Look over here. So two hydrogen atoms and two oxygen atoms, they combine themselves to make H2O. Now, if you will look carefully, over here, the hydrogen is 4, right? If you look at this is and this number, if you multiply, you'll get it 4, right? Now, on this side, the oxygen is only 2. Now let's check on the other side, the reactant, the product side. You see that the hydrogen is 4, right? And this 2 is along with the, or the 2 or the number that is written in the normal script, that is for the whole, all the elements that are there in a compound, right? But the number that is written in subscript is just for that particular compound. So this 2 is just for the hydrogen, not for the oxygen. But this 2 is for both oxygen and hydrogen. So if you combine these two, your hydrogen is 4 and your oxygen is 2, right? See, H2 molecule, two H2 molecules, that gives you 4 units of mass, plus 1 O2 molecules, that gives you 36 units. Now, each oxygen is your 18. So 18 times 2 gives you 36, right? Now the product is 2 H2O molecules, each of 18 units is 36 units, right? Both the sides, it is a balance. Both on one side, it is again 18. On the other side, each on one side, each unit is 18, and on the other side, you together has 36, right? So 18 plus 18 on one side, on it gives you 36 only, and on the other side, it's combined, that also gives you 36, right? For example, you can take this as when a candle burns, the wax doesn't disappear, right? The wax doesn't disappear, but it becomes gas and soot, keeping the mass the same, right? The wax doesn't disappear, but it turns into the flame, the gas basically, and some of the part, comes down as the candle wax. So that keeps the mass same. Okay. Now let's move on to the second law of motion, second law of chemical combination. Sorry, not the law of motion. Yeah, so that is the law of constant proportions. Now, what is this mean? What does this mean? Law of constant proportions. See, the recipe is always the same. That's the rule. That's the rule. What is the law of constant proportion? Let me explain. It is also called, this is also called the law of definite proportions. This law is given by the scientist Joseph Prost, and he says a compound always has the same elements in the mass ratio, no matter where it's from or how it's made, like a pizza recipe that never changes. Okay, let's take an easy recipe though. I guess all might know not how we all might not know how to make a pizza. Let's take a simple coffee recipe or tea recipe, right? By the way, I like coffee, so I'm gonna use the coffee example. See, I like my coffee as in which, if let me take the ratio of sugar and the coffee in my coffee basically. So I like sugar as 1 teaspoon, add the coffee as 2 sachets. So I will consider it as a 2 tablespoon. Okay, the measurement should be same although, right? So this is 1:2. The measurement, the ratio of the sugars to coffee, right? So I like 1:2. So if I'm making 2 cups of, this is for one, right? And if I'm making 2 cups of coffee, that means everything will be doubled. So this one will become 2 tablespoons of sugar and 4 tablespoons of coffee, right? And I like my coffee this way only. So the recipe never changes for me, right? That's why the recipe always same. This is what we call as the law of constant proportions. The proportions to make something will always be in the same ratio, right? It's like your favorite ice cream. This is the best example. Always having 2 scoops of vanilla to 1 chocolate swirl, right? Most of the people, out there, they have some choice in how they want to eat their ice cream. So, on the cone ice cream, I just love 2 scoops of vanilla and 1 chocolate swirl. So this makes the compound predictable. So whenever I like that taste. To get the exact same taste, what I have to do, I'll have to keep the compound keep the compound in the same ratio next time, always, right? So that I get the same taste. 2 scoops of vanilla and 1 scoop of chocolate. 2:1. If I'm getting 2 same ice creams, that would be doubled. That means 4 scoops of vanilla and 2 scoops of chocolate ice creams, right? In total. Now, let's see the example. Water, or H2O, is always 1 part of hydrogen to the 8 parts of oxygen by mass. The hydrogen's mass is 1 and the mass of oxygen is 8, right? So if you know that, this would be 1:8, right? 1:8. If you take like 1 hydrogen and one oxygen, but we generally get 2 of hydrogen and two of oxygen to combine, right? So in 18 gram of water, we will have 2 grams of hydrogen and 16 gram of oxygen always, right? Now, let's see another example. For CO2, carbon and oxygen are in the ratio of 3:8. Okay. So 12 grams of carbon plus 32 grams of oxygen gives you 44 gram of CO2. Same ratio everywhere. On tip, you can check it by using by mixing the baking soda, that is NaHCO3. Now see, this is a compound that is made by Na, that is sodium, H is hydrogen, C is for carbon, O is oxygen. So this much of the elements have been mixed into it, and with the vinegar, it is generally called as acetic acid, and acetic acid and the chemical formula for acetic acid, you can say, is CH3COOH. This is the chemical formula. If you now mix these two, NaHCO3 plus CH3COOH, the fizz you get, you can try it at home, the fizz you get is the CO2, always with that 3:8 carbon and oxygen ratio. Okay, so that is what you have to make one compound of carbon dioxide. You need 3 grams of carbon in mass and 8 grams of oxygen in mass, and that is how you can make the carbon dioxide, right? And now your turn. These laws are the building blocks of chemistry. So try doodling reactions like Na plus Cl, that is NaCl, table salt. Always it is in the ratio of 1:1.5. 1:1.5, right? Or you can also quiz your friends and ask them what is the ratios of two different elements, or two different what is the ratio of a compound that is being made by two different elements. So I hope you guys got the drill, that what is the law of what are the law of chemical combination under the law of conservation of mass and the law of constant proportion, or which you also call as the law of definite proportion. So in the next part of the chapter, we'll be covering the next topic, and that is it for today. If you have any doubt, any question, you can drop it, and that's it. Thank you so much. Bye-bye.